we can say that metals and non-metal metals constitute to form a compound, and then that formation there will be charged species, and that charged species is called an ion. More simply, we can say that charged atoms are called ions. As we know that if we consider a charge, there will be a chance of positive charge and negative charge. So charges may be positive or negative. So ions can also be negatively charged or positively charged. So there will be negatively charged ions and positively charged ions. Negatively charged ions are called anions, and positively charged ions are called cations. Negatively charged ions are called anions, and positively charged ions are called cations. And a group of atoms carrying a charge is known as polyatomic ion. A group of atoms carrying a charge is known as polyatomic ion. So that's all about ions. So what is meant by ion? Simply charged atoms are called ions. So compounds composed of metals and non-metals which consist of charged species. That charged species are called ions. So if ions are charged species, then there will be a chance of positively charged ions and negatively charged ions. And positively charged ions are called cations, and negatively charged ions are called anions. And also there will be polyatomic ion. What is meant by polyatomic ion? A group of atoms carrying a charge. A group of atoms carrying a charge is known as polyatomic ion. A group of atoms carrying a charge is known as polyatomic ion. So these are all about ion. And there is also another term called atomicity. What is meant by atomicity? The number of atoms constitute a molecule is called its atomicity. The number of atoms constitute a molecule is called its atomicity. So that's all about ions and atomicity. So here, in addition to ions and atomicity, next we want to discuss about how to write a chemical formula. How to write a chemical formula. Before moving to that topic, we want to analyze that what are the symbols of some elements. So for some of the elements are here, and the symbols, the symbol of hydrogen is capital letter H, the symbol of helium is He, lithium Li, beryllium Be, boron B, carbon C, nitrogen N, oxygen O, fluorine Fl, neon Ne. So these are the symbols of some elements. So all the elements in the periodic table have their own symbols. So if we are writing a chemical formula, we can use that symbols replacing all the names. So for writing a chemical formula, we always didn't write total name hydrogen. We always use H. So H simply indicates that the element is hydrogen. If it is O, it simply indicates that it is oxygen. If it is Li, it simply indicates that it's lithium, N nitrogen, C carbon, Fl fluorine, Ne neon, B boron, B beryllium, He helium, etc. like that. So here for the formation, that means for writing the chemical formula, we always use symbols. So in regarding ions, atomicity and symbols, we discussed about ions, atomicity and symbols of some elements. All the elements in the periodic table have their own symbol. So it is something originated from Greek, or otherwise it is used as the first letter of that element, like that. So ions, there will be positively charged ions and negatively charged ions. Charged atoms are called ions, positively charged ions are called, that means positive ions are called cation and negative ions are called anions. A group of atoms carrying a charge is known as polyatomic ion. So these are all about ions, polyatomic ions, anion, cation and atomicity. The number of atoms constitute a molecule is known as its atomicity. Now we are going to discuss about how to write a chemical formula. How to write a chemical formula. So here there will be 4 to 5 rules associated. In some textbook there will be 4 rules. In some textbook there will be 5 rules. That is simply it is 4 rules. One rule is combined. That's why there is 4 and 5 rules in some text. So there will be some rules regarding for writing the chemical formula. Following that rules, we can write all the chemical formulas here. The thing is that forget about the rules. Here we have to use a trick, or here we have to more simplify. We have to write the chemical formula by using the valency, right? So how to find the valency of an element? In the previous chapter, that means not in the previous chapter, in the next chapter, that is in chapter 4, for the atomic structure, we want to discuss about how to write a valency of an element. So already in that chapter, we want to find out how to write the electronic configuration of an element, how to write the valency of an element, like that. So that is a simple procedure to write the valency. For more simplification, I write some valencies and elements and compounds here in the table. So these are some elements and compounds. This is a compound, this is a compound, compound. That means in the elements there will be some compounds are there. That's why I will mark C in that table. So elements and valencies are there. So how to write the chemical formula of this? So first we take H and Cl. How to write chemical formula of hydrochloric acid or hydrogen chloride? So hydrogen, we write hydrogen H. Valency of hydrogen is 1. What about chlorine? Chlorine valency is 1. Then we have to interchange this one. So the valency will be interchanged. So the result is H1 Cl1. So this can be almost write as HCl, because here is one, here is one. If common factor is in the subscript, we can't write that subscript. So the product is HCl, that is hydrogen chloride or hydrochloric acid. So the next one is hydrogen and sulfur. Hydrogen, the valency is 1, sulfur, the valency is 2. So how will you write? We have to interchange. So EH2S. The valency will always write in the subscript. Write as subscript. So hydrogen sulfate. Next one is hydrogen sulfate. Next one. Carbon and chlorine. Carbon, the valency is 4. Carbon, the valency is 4. Chlorine, the valency is 1. So interchanging the valency, we got CCl4. Carbon tetrachloride. CCl4, that is carbon tetrachloride. Carbon tetrachloride. Next one is magnesium 2 valency, chlorine 1. Magnesium, the valency is 2, chlorine, the valency is 1. So interchanging the valencies, MgCl2, magnesium chloride, magnesium chloride. The next one, aluminium and oxygen. Aluminium, oxygen. Aluminium, the valency is 3. Oxygen, the valency is 2. So interchanging the valencies. Now interchanging the valency, that is Al2O3. Aluminium oxide. Aluminium oxide. Next one is calcium 2, oxygen 2. Calcium 2, oxygen 2. Interchanging the valency. Ca2O2, that is Ca2O2. So here the subscripts are same, therefore we can write CaO. Next one is these are all the elements. Next we have to write the chemical formula of some compounds. Like that we consider sodium and NO3, nitrate. So sodium, the valency is 1. Nitrate, the valency is 1. It will be 1 minus, that means it is charged. It's an ion. Therefore, the charge is mentioned in 1 minus. So interchanging the valency, we get sodium nitrate as Na1, NO3, 1, which simply means NaNO3. The subscript can't write NaNO3. So sodium nitrate. Then next one is CaOH. This calcium OH is hydroxide. Calcium, the valency is 2. OH, the valency is 1 minus. So by interchanging Ca1 OH choice. Why is OH choice? Because it's a combination of hydrogen and oxygen or hydroxide. So both of them are here. So it's a polyatomic. So in that case, we have to give the bracket. We have to give the subscript outside the bracket. So CaOH choice. It is this 2 is effectively for this oxygen and hydrogen. That is why we have to give the bracket and subscript outside the bracket. So the next one, it's also mentioned, clearly mentioned in the rules. Then next one is sodium and CO3, carbonate. Sodium valency is 1, carbonate